Good morning. This is Mr. Beckstrom, and today I wanted to take a look at how to determine whether a function is odd, even, or neither. And if we remember from doing a little bit of reading, odd functions are symmetric across the origin, so that means that kind of looks like a reflection across the 0, 0 on the graph. The even functions are reflected across the y-axis, so it looks more like a reflection across the vertical axis there. And neither, which are probably most functions, are neither reflected across the origin or the y-axis. So once again, like a lot of the problems we've done, the first thing I like to do is just to graph it to see if it looks like it's going to fit one of these odd or even or neither criteria. And that's what I'm going to do here. So I'm going to pull up my calculator and I'm going to go over to y equals, put negative 3x squared plus 2. And let's go ahead and zoom standard. And this looks like a parabola whose vertex is on the y-axis. So indeed, this does look like an even function, because it does look like if we took one side of this y-axis and we reflected it over, we'd get the other side. So that's kind of what I'm going into this problem assuming, although now I need to prove it mathematically. And the way that we do that is follows. We take a look at, I got it right there, we take a look at f of negative x. Oops. Of negative x. And if once we replace x with negative x, if we get the original function back, then that's an even function. If we get an odd version of the original function back, that means if it's negative f of x, then we have an odd function. And if neither one of those are equal, then we have neither. So I always start with to check to see if it's an even function. So what I do is I do the equals, and I'm going to replace it in here, and wherever there's an x, I'm just going to replace that x with a negative x squared plus 2. All right, now what's a negative x times a negative x? Because we do the exponent before we do the multiplication. And that would just be negative times a negative is a positive. So that's just going to be a positive x squared. So this is going to come out to negative 3x squared plus 2. And look at that. We got the original function back. And that means that that is an even function. So this one here is even. Let's do a quick example of an odd function, just so you know we have that. We take a look at that. Now let's say I have the function y, and I should have had a y up here. All right, let's have this one. Y equals 5x cubed minus 3x. All right, so let's take a look at this function. Now let's say we want to see if this is odd, even, or neither. So once again, I want to go up to my calculator and take a look at it and see what I think it is before I prove it. So I go back to y equals, let's clear this one out, and we have 5x cubed minus 3x. Oops. Cubed, forgot to push that, minus 3x. All right, so once again, zoom standard, and look at this. Here's the origin right here in the middle. And if we were to look at this side, it looks like it's a reflection across the origin here. It's not a reflection across the y-axis, but it does look like it could possibly be reflection across the origin. So I'm going to go into this one thinking that it might be an odd function. But remember, we always start with to see if it's an even. So what I'm going to do here is I'm going to replace my x with a negative x, just like I did before. And then I'm going to come in through here, and wherever there's an x, I'm going to put a negative x cubed minus 3 times negative x. Oops. Times negative x. Alright, so let's see what this one is. So negative x times negative x times negative x. Well, negative times a negative times a negative is a negative, right? Because a negative times a negative is a positive, and a positive times a negative is a negative. So this is going to be 5 times negative x cubed. We're just going to kind of put it like this for right now, because that's a negative x times a negative x times a negative x. And then minus 3 times a negative x, that's going to be a minus times a minus is a positive. So that's a plus 3x here. Alright, and when I simplify that, I can pull the negative out front. So this is minus 5x cubed plus 3x. Now I can take a look at this, and I can definitely see that that is not the same as our original statement. So at this point right here, I can say, this is our original, excuse me, right here. I can definitely say that this is not even. Now I want to check if it's odd. The way I check to see if it's odd is I pull the negative sign out of the entire equation, and I see what's left. I'm going to have 5x cubed. And then if you pull a negative out here, that becomes a minus 3x. And then I see if I have a negative version of my original function. And this right here is indeed the same as that right there. So I do have a negative version of my original function, and that means that this one here is odd. This one is even. And if I would have gotten down to here and pulled out a negative and found that this was not the same as my original, then it would have been neither odd nor even. So I hope this helped. And if you have any questions, definitely let me know. And I hope you have a great rest of your week. Thanks.